Hello dear students, welcome to Wallah English channel. We are studying signals and system in comprehensive manner. Already total we completed 22 lectures and this is lecture number 23. In this course, in this chapter, we are studying classification of signals and this is part 2. Today we will see odd and even signal. Okay, in last class just we started basic of odd and even signals. Even we completed right sided signal and left sided signal, then causal and non causal, anti causal signals, energy and power signals, and just we started odd and even signal. We have solved some questions also. So first of all, tell me, am I audible properly? Audio and video both are clear to you people? Okay. So let us solve some more question based on the odd and even signal. Suppose this is given, check symmetry of the given signal cos t. So cos function is a even or odd. Graphically also you can identify whether this is odd signal or even signal, and mathematically also. Okay. See, cos is what guys? Even signal. Graphical representation of cos signal. Graphical representation of cos signal. Graphically cos signal. X of t, the cos function. From here, this is the fundamental time period, one cycle. One cycle. Point by 4. What? By 4 minus. Correct? Let's consider this amplitude is A. Here amplitude is minus, here 1, amplitude what? 1, and this minus 1. So this is the cos signal. So if you do the folding with respect to y axis, correct, t become minus t. This is x of t. T become minus t means what? T here. Between 0 and t by 4 guys. Okay. So this folding with respect to y axis, then it become this one. Yes or no? Correct. So if you do the time reversal operation, then x of minus t will be what? X of t. So from here also we can say, see, first quadrant portion one, second quadrant portion this one, both are same, both have same area, we can say same area. Similarly you can see here this one guys, okay, between t by 4 and this t, and here also looks like same. That's why this is what? Even signal, folding with respect to this x, folding with respect to x y axis. X of t is nothing but x of minus t. That's why this cos function is what? Even function. Is cos t is nothing but what? This even signal. Here? Yes, very good. Very good guys. Cos is a even signal. Very good, correct. Now next, similarly sin t. Similarly sin t guys. Sin function. Here again graphically So sinusoidal function is odd function. Is minus t by 2 what? T divided by 2, correct? This is origin 0, here amplitude is 1, is minus 1. So I am taking only one cycle, okay, only one cycle, because this is a periodic signal, okay. So I am taking observation, I am doing observation only for the one cycle. So here this is x of t, okay. What? X of t. So first folding with respect to what? T become minus t, that means folding with respect to y-axis. So folding with respect to y-axis, that means this one, yes or no? This is x of t and this is x of minus t. So this is not equal to, this is not equal to x of t, that's why the given signal is not even signal. Next is folding with respect to x-axis, amplitude reversal. So this is what? This is your x of t, correct? This is what? X of minus t. Here is nothing but minus x of minus t. First time reversal, then amplitude reversal, and it is equal to, this is equal to x of t. So that's why sine is what? It is odd function, correct? Odd signal or odd function. Done? Okay, very good. Next question is, now try this one, e power minus 3t into u of t, exponential decreasing function. Exponential decreasing function. Exponential decreasing function. Here graphically also you can say and mathematically also you can say t become minus t, So here e to the power dt q of minus t, which is not equal to x of t, so it is not an even. Now amplitude reversal, minus x of minus t, amplitude reversal, so minus e to the power dt q of minus t not equal to x of t. This is what? Neither even nor odd signal, right? Nano, neither even nor odd signal, correct? Neither even nor odd signal. How to calculate its even part and odd part? Its even part is given by, even part is x of t plus x of minus t divided by 2. So x of t, that is e to the power minus 3t u of t plus x of minus 3t to u of minus t. Amplitude is divided by 2. Clear? So this is exponential decreasing right side, this is exponential decreasing left side, and amplitude is what? 1 by 2. Amplitude is 1 by 2, correct? At t equal to 0, amplitude is what? At t equal to 0, amplitude is 1 by 2. Here, number 2, odd part is given by e to the power minus 3t to u of t minus e to the power 3t u of minus t divided by. So if you draw its odd part and even part here even part is exponential decreasing both the sides. Amplitude at origin 1 by 2. Amplitude is 1 by 2. Here is exponential decreasing right side, and here exponential decreasing left side. Okay, and at origin at t equal to 0, amplitude is what? Half by 2. This is the even part of this decreasing function. Here this is the even part. even part. First. Second odd part is how to draw odd part. So right side, see, right side, this is e power minus 3t u of t, the exponential decreasing with positive amplitude like this, and here minus e power 3t into u of minus t, it will be like this, fine. Again, this amplitude is here, this amplitude is by 2 and this amplitude is minus 1. This is odd part of this exponential. Any doubt? Clear to each and every student? Is this clear, guys? Tell me. Yes or no? Very good. So this is what all about even and odd signals. Okay. Next question. Now identify the symmetry. Sin t plus cos 3t plus sin 3t into cos 7t. Tell me whether this is odd signal, even signal, nano. I am expecting answer from each and everyone now. Whether this is odd, even or nano. See, again I am repeating, guys. Let me repeat once. Sin t is an odd function, cos 3 is an even function. So directly you can see here, odd plus even is nothing but nano signal. Okay. So this is odd and this is even. So odd multiplied by even, it is nothing but odd signal. So odd plus even plus odd, it is nano, neither even nor odd signal. Clear now? Fine. Okay. Very good. Now one more question, guys. Let us try one more question. T plus, question number 10, t plus sin t whole square, x of t equal to t plus sin t whole square. Tell me, this is odd, even or nano? odd signal, even or nano? Even signal. Okay. So see here. See, this T is what? T odd or even or nano. So T is nothing but what? Odd signal. Only T. X of T equal to odd signal. This is also odd. Okay. Sin T also odd. So odd plus odd whole square. So odd plus odd is nothing but odd, and square of odd is nothing but even signal. Right? It is nothing but even signal. The X of T will be even. Very good. Will be what? Even signal. Fine. Very good. Now next question number 10. Okay. Now graphically, how to identify whether the given signal is odd or even graphically? Just wait for a minute. Now how to identify whether the given signal is odd or even from graphical representation of the signal. Okay. So first signal, how to identify whether X of T is odd or even. So see, folding with respect to y-axis. If you do the folding with respect to y-axis, okay. So here if you do the folding with respect to y-axis, then this is between, see, 0 and 2. So folding with respect to x, again it will be 0 and 2, guys. Yes or no? And this is minus 2 and 0. So it will be between 0 and 2. So first is what? Even. First is what? Even. See, the area of first quadrant, which is equal to what? Area of second quadrant. So for even signal, first quadrant and second quadrant, or we can say third quadrant and fourth quadrant. Even signal will be what? Even and odd both signals, even and odd both the signals are both sided signal. Left side, right side both. Duration should be same for the left side and right side. Okay. Now see, for the even signal, first quadrant area equal to what? Second quadrant area, or we can say third quadrant and fourth quadrant. You can see here. Here area is 6, here area 6. Directly you can say it is nothing but even signal. Correct? It is nothing but even signal. Here in second question, see. So this is 0 between 0 and 1. This is between 0 and minus 1. This one and this one, guys. So second is a sinusoidal function. So between 0 and 1 area and between 0 and minus 1 area. So this is also what? Even signal. First quadrant and second quadrant. See, and third quadrant, fourth quadrant and third quadrant. This is also even signal. Correct? Yes, symmetrical about y-axis. Correct. So here x of t is equal to x of minus t. X of minus t. Here also x of t equal to what? X of minus t. That's why even signal. What about this one? Third question. Odd, even or nano? What about third question? Tell me, Nikhil, in comment box. What about question number 3? Odd or even or nano? Odd, even or nano? No. Here, see, this is between 0 and 2. if you do the folding with respect to, see, this is between 0 and 2, and if you do the folding with respect to y axis, then it will be what? Between 0 and between 0 and minus 2, correct? Between 0 and minus 2. So it is not same as x of t. The area should be same, first quadrant, second quadrant. Then next is area. Here area is 6 and here area is 3. So area, both areas not equal. So that's why we cannot say this is even signal. Even this is not an odd signal, it's a nano signal. Are you getting? This nano, neither even nor odd signal, it's a nano signal. Okay. Now number 4, tell me. Number 4, odd, even or nano? Number 4. Again, check once. Number 4. So here, see, third quadrant area which is equal to third quadrant area which is equal to fourth quadrant area. Here also you can see. What about this one? What about this one? Duration also you have to check. 0 and 2. This is 0 and minus 2. This is even. This is here x of t equal to x of minus t. It will be what? Even signal. This even signal. Fine. Clear to each and everyone? Okay. Next. This one, guys. This is odd, even or nano. This is odd, even or nano. So here, first quadrant and third quadrant area. You have to observe the first quadrant and third quadrant, or second and fourth. First and third, second and fourth, guys. See, here, this is the x of t signal. What? See, this is x of t. So first folding with respect to what? First folding with respect to y axis. First is folding with respect to y axis, time reversal. The next folding with respect to x axis, here, amplitude reversal, and it is overlapping the original signal. This is x of t, this is x of minus t, and this is minus x of minus t. So overlapping with original signal. That's why what? This is odd signal, correct? Odd signal. Are you getting? Now what about this one, guys? Again you can see here. See, here folding with respect to y axis, so it will be like this. Then folding with respect to x axis, so it will be like this, overlapping the original signal. Between 0 and 2, then 0 and minus 2, then amplitude reversal. So that's why this is also odd signal. So for odd signal, you can see here. For odd signal, you can see here. Second quadrant and fourth quadrant. Here you can see this is what? First quadrant and third. So for odd signal, first and third, and second and fourth quadrant you have to observe. Okay. See this one. This is what? Odd signal, even signal, nano. So between 0 and 3, and here you can see between 0 and minus 3. Tell me this is also odd signal, yes or no? This is also odd signal. Now tell me, last one is, what about this one? What about this? What about this one? Odd, even or nano? So you cannot say this, see first quadrant, third quadrant, but not looking same. First folding with respect to, see here, first folding with respect to y axis, so it will be like this, correct? X of minus t. Then folding with respect to x axis, so it will be like this, amplitude reversal will be like this. Okay. This is x of minus t. This is minus x of minus t, So here this is not equal to x of t. That's why you cannot see this is the odd signal. This is nano, neither even nor odd signal. Is this clear, Nikhil? Tell me. Okay, very good. So graphically also you can identify whether the given signal is odd, even, and nano. Now next question, this one, see here, this is odd, even, or nano. Got exponential decreasing function. So of course you can see here, this is also what, nano signal, neither even or odd signal. This is also nano signal. Fine. Clear? Any doubt? Okay, next. Now graphically, guys, see, read the question. This is given. Okay, check the symmetry and find its even part and odd part. Okay, so tell me, this signal is odd, even, or nano, guys? Tell me. Odd, even, or nano? Of course, this is only right-sided signal. Only one-sided signal, that means nano. Only one-sided signal, that means nano, guys. So of course, here, of course, you can see x of t is not equal to x of minus t, and x of t is not equal to minus x of minus 3. That's why given signal is nano. Okay. Now how to calculate? How to calculate its even part? For even part, what is the formula to find even part of the given? So even part, so xe of t, which is equal to x of t plus x of minus t whole divided by 2. So first of all, you have to draw x of t, and parallelly you have to do x of minus t. Then addition, amplitude, signal addition, and finally amplitude is divided by 2, guys. So see, this is x of t. First I draw x of t. I am drawing here x of t. Then next is x of minus t required. So folding with respect to y axis, time reversal. So you can see here, this is x of minus t. This is between 0 and 3. This is between 0 and minus 3. So this is x of minus t, and this is x of t. Now you want to calculate even part first. First we want to calculate even part. Even part. So how to calculate even part? So amplitude addition, guys. Time by time, amplitude addition. Amplitude addition here. Signal addition and amplitude is divided by 2. So this portion plus this and divided by 2. So here this is 0, guys, and this amplitude is 1. Okay. So right sided it will be like this. But amplitude is half, guys. Amplitude will be half. Amplitude is 1 plus 0. The 1 plus 0 divided by 2. Don't forget this one. So amplitude will be 1 by 2. Similarly, left side 0 plus this, 0 plus this. So this is what? Given signal minus 1, 0, 1, 3, minus 3. Okay, the even part. One part of the given. Fine. In this way, we can find the even part. Okay, clear? Now next, calculate the odd part. So how to calculate odd part? Odd part formula is, odd part is given by, now subtraction x of t minus x of minus t whole divided by 2 guys. Okay, so x of t minus x of minus t, time by time subtraction, amplitude subtraction. So it will be like this. Already I taught you how to do signal addition and signal subtraction. The odd part. So this minus this, it will be again amplitude is half. Here amplitude is 1, it will be 1 by 2. Now this 0 minus 1, it will be minus 1 guys. 0 minus this, that means here this is 1 minus 1, this is minus 3, again 0 minus 1 divided by 2 will be again minus 1 by 2. This is what odd part of the given signal. Clear? Any doubt? Clear or not? Correct? Graphically signal addition, signal subtraction, and finally amplitude is divided by 2. Fine? Now try this question yourself. This is x of t. Again, this is also what guys? This is also nano signal. So find its even part and its odd part. Find its even part and odd part. So first draw x of t, then draw x of minus t, then signal addition, and then signal subtraction for the odd part. Okay, try this question yourself and tell me which option should be correct answer. Okay, so first how to find its even part. Even part is given by x of t plus x of minus t divided by 2. So first draw x of t, then folding with respect to axis. So this triangle between 0 and 2, now between minus 2 and 0, and this is folding with respect to, see, folding with respect to what? Y axis. So time reversal. So this is x of minus t, this is x of t. Now add these two signal and finally amplitude is divided by 2. So the resultant signal is 0, 1, 2, minus 1, minus 2. Now see, here amplitude is 2, so 2 plus 0 and divided by 2. 2 plus 0 and divided by 2, guys. See, amplitude is 2, here 0. At t equal to minus 2, here 2, at t equal to minus 0. So 2 plus 0, amplitude addition, and divided by 2, so it will be 1, correct? Here 1. And next, 2 plus 2, so 2 plus 2, 4, divided by 2, it is nothing but 2. Next here, this is 0, 0 plus 0, 0, divided by 2, that is 0, guys. Okay, and here this is 2, so 2 plus 2, 2 plus 2, 4, 4 divided by 2, that is equal to 2. And here is 0, 0 plus 2, 2, and 2 divided by 2. Here amplitude is 0, amplitude is 2, 0 plus 2, 2 divided by 2, that is equal to 1, guys. Here 1. So this amplitude is 1, then this point, then here this point, this, fine. Clear? So this is what even part. One part is, here we got 1 amplitude, then amplitude is 2 here, then 0, then again 1, then 1, so this amplitude is 2, guys, this amplitude is 1. So this is even part, the even part of the given signal, fine, even part. Now next we have to find its odd part. So for odd part, signal subtraction, amplitude is divided by 2. How to calculate odd part? Odd part is given by x of t minus x of minus t whole divided by 2. So this is x of t. Now subtraction, signal subtraction, guys. Okay, time by time signal subtraction. So here 2 minus 0, 2 minus 0, guys. So 2 minus 0 2, 2 minus 0 2 हो जाएगा, and amplitude is divided by 2, तो कितना हो जाएगा ये 1, सॉरी 2 minus 0, yes, 2 minus 0 2 डिवाइड बाई 2 करोगे तो हो जाएगा 1, यहाँ पे 1 आएगा. नेक्स्ट 2 minus 2, guys, here amplitude is 2, 2 minus 2 कितना हो जाएगा, 0 हो जाएगा. And here this is 0 minus 0 कितना हो जाएगा, 0 हो जाएगा. And here again 2 minus 2 0 हो जाएगा. Correct? Here this is 0 minus 2, guys, 0 minus 2. Okay, 0 minus 2 कितना हो जाएगा, 0 minus 2 करोगे तो minus 2 आएगा, डिवाइड बाई 2 करोगे तो -1. तो यहाँ पे आ जाएगा ये -1. तो ये है 1, फिर हुआ 0, अगेन 0, अगेन 0, देन -1. ये हो जाएगा आपका ऑड सिग्नल. Here is what? Is odd signal. This is 1, then 0, 0, -1. Okay, and amplitude is divided by 2. Remember this thing, amplitude divided by 2. So it is 1, this is -1. Done. In this way we can calculate odd and even. Is clear in everyone? I hope all of you are getting. So this is all about what? This is all about for the continuous time signal. Okay, and till now we have seen symmetry condition for pure real and pure imaginary value signal. Pure real and pure imaginary, the previous amplitude is divided by 2. Yes, of course, divided by 2. Here also amplitude is divided by 2. See, this is 2, here 2. So 2 plus 2, 4, and 4 divided by 2, that is 2. And here 2 plus 0. So 2 plus 0, 2 divided by 2, that's why here 1. Got it? Now next symmetry condition for the complex value signal. Suppose x of t is a complex value signal. Then what about the symmetry condition? Till now we have seen the symmetry condition for the pure real and pure imaginary value signal. But suppose complex value signal is there, then what is the symmetry condition? Let us consider x of t is a complex value signal. Complex value signal means x of t is equal to a of t plus a b of t. Let us consider this is a complex value signal. Then for every conjugate even signal or it is also known as conjugate symmetric. It is also known as conjugate symmetric signal. For every conjugate even signal or conjugate symmetric signal, x of t is equal to x conjugate of minus t. First, folding with respect to x, that is t become minus t, then conjugation also. Conjugation means j plus j become minus j become plus j. So first folding with respect to x is, then plus j become minus j, and if it is equal to x of t, then we can say conjugate symmetric signal or conjugate even signal. Similarly, for every conjugate odd signal, x of t equal to minus x conjugate of minus t. So first t become minus t, first time reversal, then amplitude reversal, and finally conjugation also. Okay, and same condition for the discrete time signal also, and it is also known as conjugate anti-symmetric. Conjugate anti-symmetric. You get anti-symmetric signal, and the signal which is not satisfying above two conditions is said to be neither conjugate even nor conjugate odd signal. Fine. Same condition for the discrete time also. X of n is equal to x conjugate of minus n. Similarly here, and we can say the discrete time x of n minus x conjugate of minus. Fine. Clear or not? Okay, very good. Now let us solve some question based on this. Okay. Now how to find conjugate even part and odd part? So how to find conjugate even part, odd part? Conjugate even part is given by same formula, x of t plus x conjugate of minus t divided by 2. X of t plus x conjugate of minus t whole divided by 2. Right? And conjugate odd part is given by odd part x of t minus x conjugate of minus t whole divided by 2. This is for the continuous time, and same thing is applicable for the discrete time signal also. Xe of n is equal to x of n plus x conjugate of minus n whole divided by 2, and its odd part is given by x of n minus x conjugate of minus n whole divided by 2. Fine. Okay, now let us solve some question based on this topic. So first question is given, check symmetry of the given signal, conjugate even signal, conjugate odd signal, or nano. You have to tell whether this is conjugate even, conjugate odd, or nano. First t become minus t, t become minus t. See, this is the complex value signal, real part and imaginary part both are present. T become minus T, so here like this. Then conjugation also, guys, correct? In conjugation, J become minus J. So J become minus J, guys. J become minus J and equal to x of T, which is equal to x of T. Okay. So this is what here we got x of T equal to x conjugate of minus T. That's why this x of T is what? Conjugate even. Conjugate symmetric, or we can say conjugate even signal. Here, fine. Very good. Very good. Now, next question. Let's try next question. Try your self question. T into e power jt. Next question is T into e power jt. Tell me whether this is conjugate even signal, conjugate odd signal, or nano, conjugate nano. Conjugate odd. Okay, very good. Let's check. So first of all, T become minus T. T become minus T means here minus T the power minus, and then conjugation. Conjugation J become plus J. Minus J become plus J. Then amplitude reversal is not equal to x of T. That's why not conjugate even. Now amplitude reversal. So amplitude reversal, so it is plus T e to the power jt. Okay. T become minus T, then J become minus J. So this is, I think, nano. I think this is nano, guys. Check once. T become minus T, e power minus jt. Sorry, not nano. It is same as the x of T. That's why conjugate odd. Same as x of T. Here we got x of T is equal to x conjugate of minus T minus x conjugate minus T. It is conjugate odd signal. Conjugate odd signal. Fine. Okay. Very good. Conjugate odd signal. Clear? Now try one more question. This one, e power jt. Tell me your answer in the comment box. E power jt. Whether this is conjugate symmetric or anti-symmetric. Odd, even, or nano? Tell me, this is conjugate odd, even, or nano? Tell me in comment box. Conjugate odd or even or nano? Here T become minus T power minus jt. Now conjugation, x conjugate of minus T is e to the power jt, correct? Conjugation, guys. So this is equal to what? Same x of t conjugate e1, guys. This is what? Conjugate e1 signal, conjugate symmetric. Conjugate e1 or conjugate symmetric. Very good. Very good. Now this one, t square plus jt power 4, conjugate odd or even or nano. I am expecting answer from each and every single student in the comment box. Conjugate even, conjugate odd or nano. Okay, this is nano. Very good. T become minus t. T become minus t, t square. Here also t become minus t. It will be t to the power 4. Now conjugation is a complex value signal. Conjugation, that's why conjugate, that is t square minus j t to the power 4 is not equal to x of t. This is not conjugate e1. Conjugate e1. Now next is minus x conjugate of minus t. Okay, so here amplitude reversal, so minus t square minus j t power 4, okay, which is not equal to x of t, is not equal to x of t. Fine. Okay, so this is what? Nano signal, neither conjugate even nor odd, nano signal. Fine. Here. Okay. Now try this question also. T plus jt, conjugate odd, even or nano. Then we will see the important observation from all these questions. Tell me whether this is odd or even or nano. Odd, even or nano. Conjugate odd, conjugate even, or neither conjugate even nor odd. I am expecting answer from each and everyone. Again nano. Okay, very good. See, t become minus t minus j t cube. Then conjugation minus t plus j t cube. Then amplitude reversal. Amplitude reversal, so t minus t cube. So here you can see this is also not equal to x of t, and this is also not equal to x of t. So again, this is neither conjugate even nor conjugate odd, nano signal. Fine. Now important observation for all 4 questions. First of all, this one, number 2. See, this is what? Conjugate odd signal. Conjugate odd signal. So x of t, can we write like this? X of t is important observation. First signal x of t power, and this is what? Conjugate even, conjugate even signal. Now in this x of t, x of t is e power j theta, Euler's form, cos t plus j sin t. Okay. So as you can see here, the real part is what? E1 signal. Real part is E1 signal and imaginary part is odd signal. Sin t is the odd and cos t is the first observation. Second question was t into e power jt. P into e power jt, that is nothing but conjugate odd we got. So again observation, x of t is equal to, again Euler's theorem, sorry Euler's form, e power j theta equal to cos theta plus j sin theta. So t cos t plus j sin t. Now this guys, this real part is odd or even? Real part. This imaginary part is odd or even? Real part, tell me. So this is odd signal, t is odd signal, cos t is even signal, even into odd is even. Now t is odd signal and sin t also odd signal guys, so odd into odd it is even. Wait, t cos t plus j t sin t. So here it is odd signal multiplied by even, it is odd, my mistake. It is odd guys, odd, real part is odd and odd multiplied by odd it is even. So here you can see real part is odd and real part imaginary part is even. For the conjugate odd, third question, x of t is equal to t square plus j the power 4. It was a nano signal, neither conjugate even nor odd. So x of t is equal to x of t is equal to t square plus j power 4. Now real part is also even and imaginary part also even guys. Both are even and the x of t is nano. Similarly, fourth question was t plus j t cube. This was also nano, neither even nor odd. And here observation is x of t is equal to t plus j t cube, because odd, this is real part is odd, imaginary part also odd. What is the observation? Observation is what? If real part for the complex value signal, if real part is even and imaginary part is odd, then the given signal will be conjugate symmetric, conjugate even. If real part is odd, imaginary part is even, then it will be conjugate odd. And if both real part and imaginary part, both real part and imaginary part are even or odd, both even or both odd, then it will be nano signal. This clear? So this is very much important observation. So let me write here. So real part, first case, the real part is even, and imaginary part is odd, then tell me the symmetry. Real part is even, imaginary part is odd, then the symmetry is conjugate symmetric or conjugate even. X of t is, this is for the complex value signal, conjugate symmetric or conjugate even guys, conjugate even signal. Now if real part is odd, imaginary part is even, and it will be conjugate odd signal. Conjugate odd. if both real part is even and imaginary part also even, both even, then it is what? Neither even nor odd. There is no any symmetry. Okay, nano. And again same, both odd, then it is also nano. Fine. Here every friend. So this is very much important observation. So this is all about what? Symmetry condition for complex value signal. Already we have seen for the pure real, pure imaginary, and this is all about for the continuous time signal. In next class we will see for the same concept for the discrete time signal also, guys. Okay, so all of you, thank you so much. Let me finish this lecture here. So all of you, thank you so much watching me live on Get Wallah English channel, and please provide your valuable feedback after completion of this session, and next part we will continue into subsequent module. Thank you guys, thank you so much.